Dr. N. Gautam Rao sir. Good morning to our faculty and my dear friends. Welcome to the session. Today we all are gathered here to hear a presentation on dynamic testing of aerospace structures, vibration and shock by Sri Veera Reddy sir. Now I request our Chairman sir Dr. N. Gautam Rao sir to come on. Now I request our Chief Guest Veera Reddy sir to raise the case. Now I request our Chairman sir to handle the bouquet to Chief Guest Veera Reddy. Before the presentation, I would like to read the profile of our Honorable Chief Guest Veera Reddy sir. Sir has completed his BTech in Mechanical Engineering from Nagarjuna University, Andhra Pradesh in 2001. Later, he did his post-graduation in Machine Design from IIT Guwahati in 2003. He joined as Scientist B in Research Center, Imarat under DRDO. Presently, he is working as Scientist E. His areas of specialization are dynamic testing and structural analysis. He is pursuing his PhD in Machine Design from IIT Hyderabad. His research topic is systems involving indigenous design and development of 500 kg payload pendulum shock machine for shock testing of missile systems. Design and development of 4-ton water-cooled electrodynamic shaker. This shaker developed enhanced the indigenous development of critical spares for the existing systems which are under embargo. Post-flight vibration, data analysis of missile flight trials. Now I request sir to handle the session.
I will be talking on dynamic testing of aerospace systems. So basically when we say aerospace systems, so we assume that most of them are designed very well, suppose. So we are not talking about the design phase. I assume that, or I presume that design is done very well. Now, what are the other criteria that you should take care of? So you should take care of the environments. What all it undergoes, right? Say from its production stage to deployment stage. So the environments I have listed in the slide. See, there can be two environments. One is called induced, means say dynamic environment. These are all man-made due to man creation or man inherently. It comes. It doesn't come inherently. It is due to man interpretations. So these environments are listed. So these are also called dynamic environments. You can see here. These are all listed. So in this, mostly this is the area where we get more failures, like vibration. And other area will be this shock and bump. These are all same. I will give in detail what are these in when I go to the slide. So other acoustics is due to some sound vibrations. Acceleration means when I say if it is a aerospace like aeroplane or say for us a missile, when it takes some turns or some acceleration, then it has some kind of load that comes onto it. This is when there are some missiles or say structures which when they re-enter after going to some altitude, and when they enter the atmosphere again, lot of heating is being done. I will show you some videos where just due to this kinetic heating, some of the satellites or say launch vehicles are failed. Basically Columbia disasters. So EMIs is like magnetic interference and shielding effects. We will talk about this in detail. So other environments are like this. So natural means due to its naturally being either stored in that condition or due to operation condition you get these environments. So what are they? Basically temperatures, low temperature, high temperature, or it can be suddenly from low temperature to high temperature, or some kind of environments where you have a lot of dust and sand, or lot of heating is there, and some kind of fungus and algae growing, or say very near coastal area where you have a lot of humidity and this corrosions taking place. Due to these temperatures or say environments, you have some failures. So in these environments, where all we apply? I will listed the application industries. It can be aerospace, automobile, nuclear, heavy industries, electronics, appliances. Due to ever demanding of better and better products, now even automobile and even commercial industries are coming up with the quality and quality plan for improving their products. Suppose you can see initially when Nokia started its mobile first, it had a very good resistance to drop, means shock. You could see nothing could happen to your mobile when it is dropped. But due to the latest versions, due to cost cutting technologies, you can see now the new Nokia mobile if you drop more times, it has some susceptibility to drop. Means some of the parts are going bad or something is happening to the electronic parts inside, which quality has come down at the cost of reducing the cost. So it is a area where you need to improve upon your product, but again you have to see whether you are fiddling with your performance or with any other thing. So even in aerospace industry, we need to know all these environments and as to design the things accordingly. So when you do the test, the simulations we can't take this product. Suppose if I want to do a low temperature, I can't go to a place where the temperature is there. But what I do is, I do all these tests in laboratory. So how do I do? I do simulate all these environments using certain equipments. So when I do simulate these tests, what are the different types of tests are there? I have listed. So I will explain in detail. What are the qualification tests? What do you mean by qualification? What do you mean by acceptance test? And how do you create and do all this? Is there any standards when you want to do this? Definitely every system, whether it is a design or testing, there will be some standards. You will see. And some other aspects when you want to do these testing, you should know that. So as I told you before, there are either dynamic testing or we will say climatic testing, because dynamic is man-made. These are the things which we will do. These I have listed with respect to our missiles. That means, where do we get this? I will tell you on the next slide. The climatic also, these are the things that we do actually, specific to our missile testing. So why we do all these testings? These are the reasons actually. When we do testing, we want to verify whether our design is okay or not. Whether are we having any design margin, whether in that environment our system will perform, or are we going to see surprises, or there are going to be any failures for the products that we make. So for that, so to be precise, it is like to confirm the structural integrity under different environmental conditions and evaluate the performance to be within the specified limits. This is our requirements. For example, you see, a mission can be lost just because of one resistor being not giving its value. So that is a kind of precise success that armed forces or the people are looking for. See, but we all know resistance is a function of temperature. So due to change in temperature, resistance can vary. So that change in resistance can cause a failure to me. So I should know beforehand all these changes and account for all the failures that are expected. So here I have also listed environments and where it comes into flight. In detail you will see. And just to show you a relationship between the failures that have happened in our missile up to now and the environments. So most of the failures have come from temperature side, followed by vibration, then humidity and so on. So if you take a 100% failure, this is the graph that we got actually. So temperature is responsible for most of the failures. So I should design my all electronics. You know, most of the electronics require fins and other cooling mechanisms to dissipate heat. So if you have a problem in that, then your system is going to fail. The next is the vibration. So these two are the major dominant failure modes in our avionics. So we attack them. How we do, we will see. Then you should also know what is screening. Actually, see, screening is like, it has three phases of its life. Every product has three phases. It will be either early period or after some. When this early period, failures are more due to this called bathtub curve. Early period, the failures are more due to its design being not fully conformed. So once the design is frozen, then you will not have failures. You will have good life. So again, due to the later on, I mean after using for some certain years, the failure will start increasing due to the wear and tear. So this is the general behavior of any system or say component. That's how it behaves. So knowing these things, now we have to design how to increase the product life. This is again same. Why in each period what will happen. So now let us in detail look for different things. So in dynamic testing, I will be looking for these things basically: vibration, followed by shock and pump and acceleration. See, in vibration, how do we simulate, and shock and pump, how do we simulate, this acceleration, how do we simulate, how we get all these environments, all this we will see. See, before coming to vibration side, I just give you few basics of vibration. Everybody know what is vibration? It is to and fro motion, about a mean motion. But the three basic components that form the vibration force, or say vibration causes, are mass, that is inertia, then the damping and the stiffness. See, each of them I have just listed here what they mean is. Suppose if you take a spring as a stiffness, it is responsible for storing potential energy in the form of, say if you have a spring, you compress it, it gets compressed by say amount D. Then this is the spring force which is causing or say which is storing that energy. If you take damper or say, ideally we have taken viscous damper here. Then if the force, viscous force is proportional to the velocity. So the force is given by C into V. The energy dissipated from the system is C into V. And the mass which is responsible for inertia force is mass times acceleration. And if you see damping, there will be so many types of damping. Here ideally we are talking about viscous damping. So these three basic components determine any structure's vibration behavior. So now wherever you get sources of vibration, whether it is aerospace or from our missile specific, it can be generated by this. Any motion or mechanical force. Few places where it comes I have listed, like say combustion and rotation of automobile engine and drivetrain due to imbalance, irregularities in road surface. Suppose if a vehicle is moving on road, from the road tire to the chassis, due to the irregularities on the road, you get a transmission of vibration, and from the chassis to the person sitting inside or the structure you get. Then you also get due to, for our machine, due to burning of propulsion, this gas flows in pipes or so. And also due to the initial lifting of rocket or say missile, that high energy, sound energy which is there, you get. And as the aeroplane or say missile moves over considerable altitude, you have aerodynamic force which is coming, which is responsible for crossing this. You also get due to some other things like this, imbalance and when you move or walk or something. So for specific to our missile industry, we get these are the vibrations due to the lift off, then ignition, then stage separation and propulsion actually. So and the frequency of our vibration ranges, if you see, there are different industries have different frequencies. Once if it is a missile lifting and due to the aerodynamic excitation, we get the frequency in the vibration is up to 2 kilohertz. Whereas if it is transportation on the road, just due to the vibration transmission, it is up to 500 hertz. It is same. So again, these are the frequencies of different industries. If it is aerospace industry, it is 2000 hertz. If it is automobile industry, it is 5000 hertz. If you consider train, it is 1000 hertz. If it is a ship, it is 33 hertz. These frequencies are important because knowing the frequency ranges only, we should design our system. Like if you are designing a system for 500 hertz in aerospace industry, it may fail. But if you are designing a system for 2000 hertz in automobile industry, it will become a over design. So you should know the frequencies of excitation, and so you accordingly you design. These are the frequencies for different industries. And now what is the effect of vibrations? See, you have seen the sources, you have seen what are the ranges of frequencies it happens. And what does the vibration do? Basically vibration is a to and fro motion. So it is often expected that fatigue cycle will come, so it may fail due to number of cycles. And there may be some kind of O-rings, seals which are susceptible to vibration, which may damage. We will see some of the failures have occurred due to O-ring of one of the space shuttle. That was Columbia disaster has happened just because one of the O-ring has failed due to the initial launch. So these will be very critical. And then there is a propulsion system inside sitting, which is responsible for taking the rocket to different heights or say velocities. So if the propellant is debonded, means the grain-to-grain bonding is weakened, then also the combustion will go into instability and then the system can fail. The vibration can create such a debonding of propellant, and there are some bolts, fasteners which get loosened due to the vibrations. Apart from this, there are some electronic components sitting inside which will have failure due to the vibrations, like say PCB, or then there can be misbehavior of relays. These are very susceptible to vibrations. Or there can be some noise generated in the electrical signals due to the vibrations. Or there can be chatter and other changes in the capacitance, resistance, inductance can be caused due to vibrations for a momentarily. But that momentary change it can cause a failure due to the strict specification that is required. And now, having seen only disadvantages of vibrations, we also have some advantages. If you see closely, we are able to speak or say we are able to listen due to the oscillations of the sound waves. So this is one advantage. We are both that. And in our ECGs and other signals, we are capturing the vibrations of the heart. So that is our advantage. And not only that, see, the vibrations, by knowing the vibrations, you can say fault detection you can find out. Like if you say, if you have a pot, if there is any say crack, if you tap it and say, you will see some different sound. That is the olden days people used to identify whether the pot is cracked or it is good or bad. That's called the old method. And if you see now what we do is, when we subject in our missile systems to different kinds of environments, and we take something called response. Means we will see the health of the system by knowing the response, by which we know whether the system is good or bad. So this is one of the advantages of vibrations. And now you can see always road digging, cutting, all this. These are just possible because of these vibrations transmitted from the pile drive. And now I will show you a few slides where the vibrations have caused a major mishaps. So these mishaps have been one of the. This is one of our system which has failed due to vibration. This was a design failure. So we have designed this. This is a missile actually. It is supposed to undergo helicopter vibration of 500 Hz. So when we were testing it, you will see that it has debonded and it failed. We could fix this problem not less than 9 months. We could take around 9 months to solve these problems. Here the problem was that there was a bonding between a metal and the FRP. The joint was failing due to so many reasons. The vibration was so high. Likewise, this is a Tecumseh narrow bridge which was installed in 1947 or 40 somewhere in Washington. This is a bridge built on this rods, what we call suspension bridge. Suspension bridge has a number of tie rods. After 8 to 9 months of its inception, it failed due to 2-3 reasons. One was also design failure due to actually that day wind was flowing at 40 to 50 kilometers per hour. So the bridge got into its twisting mode and later on bending mode. Both coupled together, later on it failed actually. One of the professor was there on the bridge that day, but he could later on come out. This failed. This was one of the major catastrophic damage in the history of bridges actually. It was a design failure. There are 2-3 facts in this construction. which later on professor showed that even simple calculation by hand could have averted the damages, which they did not take care. One was that like this bridge had some columns which were closed from one side actually. So when the wind has come and hit the bridge started oscillating. Had the columns been open, the wind should have passed simply through, and then this failure should not have happened. So like that simple. This is again one of our systems which has failed due to say wrong selection of isolators. Isolator, when we mean, is a system which is put to protect another system. See, this is a PC used by one of defense services. This is a very delicate system. This cannot withstand level. So to protect this system, we use something called isolator. It is like a resilient element in between the source of vibration and the system. So here they have chosen a wrong set of isolators. So that caused the vibration input to amplify, and rather than protecting the system, it damages the system. You can see violent oscillations of the system. And actually, we having noticed it, we stopped it. We did not allow it to fail completely, but it still failed. This is the flutter. Sometimes in aerospace industry, when the wings are not designed properly, you get flutter. Such kind of system in this. Right. This is again one of the space shuttle which failed. You see the video. This was due to one of the O-ring which failed. During liftoff, here it shows the comparison. Actually, the same thing repeated again in 2003. Another Columbia has failed. So you will show the difference between the two. Just see. One was the O-ring failure. One was the there is a shielding which they do for the re-entry side. When the shuttle enters the atmosphere at very high speeds, so they will have some thermal protection given on the space shuttle. So during the liftoff, a portion of the thermal treatment given was burned. So while re-entering, that had become weakened, and then the mission was lost. The Kalpana Chawla was lost. You must all seen this video.